Okay, intermediate algebra, let's do the last section for this chapter, dividing polynomials. Now we already saw with our exponent rules that when you divide with the same base, you subtract exponents. So recall these two problems from section 4.1 and 4.2. We divide coefficients normally. Negative 48 divided by negative 12 is 4. X cubed divided by x is x squared. Y to the fifth divided by y to the fifth is y to the 0th. Put anything to the 0th power is just 1. So this is just 4x squared. This is nice, but again, these are both single-term polynomials, which makes it easy to divide. So what happens when our numerator has multiple terms and then potentially our denominator has multiple terms also? That's going to change our approach. So the easiest way to explain what's happening when our numerator has multiple terms is let's talk about 2 plus 5 over 3 with just numbers. Remember that numerators can be separated into separate fractions. So 2 plus 5 over 3 we know is just 7 over 3 if we add, but it can also be separated into 2 over 3 plus 5 over 3 to get that same 7 over 3. So we can do the same thing even when variables are involved. So generally speaking, you can separate everything into its own fraction, every numerator into its own fraction, and it's all over the denominator, because remember, everything's being divided by the denominator. Now, if you have multiple terms in the denominator, you cannot separate those. Only if there's one term in the denominator and multiple in the numerators can you separate. So let's look at 15x to the 6th plus 10x to the 4th over 5x. We can take each term in the numerator and put it over 5x, and then divide from there accordingly. 15x to the 6th divided by 5x to the 6th is 3x to the 5th. 10 divided by 5 is 2. X to the 4th divided by x is x cubed, because remember this is to the 1st. So it's pretty easy when your denominator only has one term still. It's not that bad. 24y to the 7th plus 12y cubed minus 20y squared all over negative 4y squared again. Put everything over the denominator. Now, one thing that I will recommend is when you have minus signs in the numerator here, always put a plus sign and take the negative with you so that you don't confuse yourself when you're dealing with the division. If I put a minus out there, you may get confused with a negative divided by negative, so it's just easier this way to turn it all into addition. 24 divided by negative 4 is negative 6. Y to the 7th divided by y squared is y to the 5th by subtracting. 12 divided by negative 4 is negative 3. Y cubed divided by y squared is y. Negative 20 divided by negative 4 is positive 5. Y squared divided by y squared is y to the 0th, which is just 1. So they cancel, and you're left with negative 6y to the 5th minus 3y plus 5. I'll let you do, actually, let's do number 3. 12a cubed plus 9a squared plus 6 over negative 3a squared. So again, everything gets its own. Okay, so 12a cubed divided by negative 3a squared, that would be negative 4a. 9a squared divided by negative 3a squared is negative 3. The a squareds cancel. 6 divided by negative 3 is negative 2. But there's no a to cancel out. That means the a squared stays in the denominator. We don't have anything to get rid of it. It would really be a to the negative 2nd, as if this were a to the 0th. Then if we subtracted, we would get a to the negative 2nd, but we know for negative exponents, we move them down. So sometimes you can have stuff left over in your denominator. Similarly, sometimes you have multiple terms that you've got to deal with, like number 4. But again, as long as you split your numerator and everything's over the denominator, you'll be fine. Negative 28b to the 4th c cubed over negative 7bc to the 4th. that would be 4. When I subtract b's, 4 minus 1 is 3, b cubed. 3 minus 4 for the c's is c to the negative first, and we'll move it in a second. 35 divided by negative 7 is a negative 5. There is no b here, so it would be like there's a b to the 0th, minus b to the first is b to the negative first. C to the 6th minus c to the 4th is c squared. And lastly, negative 49 over negative 7 is positive 7. B to the 6th divided by b is b to the 5th. And then this is like there's a c to the 0th. 0 minus 4 is negative 4. And remember, anything with a negative exponent goes to the denominator and becomes positive. So 4b cubed over c to the positive first, which is just c, minus 5c squared, that's positive, over b, because that one was negative, plus 7b to the 5th over c to the 4th. So these can get pretty complicated with lots of terms and some larger terms in the denominator, but it's still the same strategy. Now, in addition to this, we have some word problems that use the same idea. The area of a triangle is given by the polynomial 8m cubed plus 12m squared minus 4m, and the height is given by the polynomial 4m. What polynomial represents the length? So we'll call it the base more appropriately. So remember, the area of a triangle is 1/2 base times height. Now they said we know the area. It's 8m cubed plus 12m squared minus 4m equals 1/2. It says the height is 4m, so times base times my height of 4m. What's half of 4m? 2m. So that's 2m times b, and it wants to know the base. That means I need to divide by 2m. And remember, if we divide by 2m, it goes to every term. Like that. 8m cubed divided by 2m is 4m squared. 12m squared divided by 2m is plus 6m. 4m over 2m minus 2. So my formula for the base, or length, is 4m squared plus 6m minus 2. Another question, what polynomial, when divided by 3z to the 4th, gives the polynomial below? So we have some polynomial, which we'll call p of x. When it's divided by 3z to the 4th, we get 17z to the 5th minus 8z cubed plus 15z minus 9 over z. How do I find what this polynomial is? To get it by itself, I actually have to multiply 3z to the 4th to the other side. So really, this isn't a division problem. It started as division, but really we have to use multiplication to solve it. 3z to the 4th now has to be distributed to every single term. 3 times 17 is 51. Z to the 4th times z to the 5th is z to the 9th. 3z to the 4th minus 8z cubed, that's negative 24. Z to the 7th. 3z to the 4th times 15z is plus 45. Z to the 5th. When you multiply a whole number by a fraction, it multiplies into the numerator. So this will be minus 27z to the 4th over z. But what is z to the 4th divided by z? It is z cubed. So the polynomial is 51z to the 9th minus 24z to the 7th plus 45z to the 5th minus 27z to the 3rd. And we will continue in the next video.